In this video, I'm going to look at several different approaches to solving the burning tent problem. You are in a forest, you look over at your tent, and, oh my gosh, it's on fire. Luckily, you have a bucket in your hand, and you can run over to this river and fill your bucket with water, and then dash over to the tent to douse the flames. The question is, where along the river should you run to minimize your total running distance? Let's model this with Web Sketchpad. I'm going to use the segment tool to draw a segment from you to the river's edge and from the river's edge to the tent. And this point can be dragged anywhere along the river's edge. Let's give this point a name. I'll use the label widget to tap on it, and let's call it P. Where should P be located to minimize our total running distance? Well, there's a very clever approach to solving this problem, and it involves reflecting this point tent across the river's edge. So let's do that using the Reflect tool. I'll tap on the tool, and I see a preview of the point that I'm going to reflect, and the mirror line, and the reflection of that point. The point that I'm going to reflect is glowing, so let's merge that point to the tent. Now the line of reflection is glowing, indicating that I should place that somewhere, so let's tap on the river's edge to merge those two together. And there, I've reflected the tent across the river to obtain a new point, and we can label that as tent prime. All right, so if I travel from U to P to the tent, a key insight here with this approach to the problem is that that is the same distance as traveling from U to P to tent prime. And I'll leave that to you to explain why. So if I'm traveling from U to the tent prime, clearly this is not the shortest path. If I want the shortest path, I should connect U and tent prime with a segment, and then I can mark this point here along the river to show me where I should actually run to minimize the distance. So right there. And what's nice about this construction is I can now drag U or the tent to different locations, and each time I do, it shows me the correct place to run to minimize my total distance. So that's the first approach to this problem. Now I'd like to take a look at another approach that's based on the book Connected Geometry, written by EDC in the mid-1990s. Once again, we have U and the tent, and I'll construct segments to show our path. And let's label that point again as P. All right, now we no longer have a reflection tool, and instead we have an ellipse. How can an ellipse help us solve this problem? Well, I'm going to construct an ellipse, and I'm going to make the focal points of the ellipse U and the tent, and the ellipse is going to pass through point P. And after I do that, we can look at why having an ellipse here can help us solve the problem. So I'll tap on the ellipse tool, and one of the focal points of the ellipse is glowing, indicating that I need to place it. So I'll merge that to point U. Now the other focal point is glowing, I'll merge that to T, and a point on the ellipse itself is glowing, and let's merge that to P. We now have an ellipse with focal points at U and the tent that passes through point P. I'm going to put another point on the ellipse, and let's call that point, how about point Q? And I'm going to connect that with segments. If I double tap on this tool icon, it keeps the tool active each time I use it, so I don't have to go back and tap it again. All right, I now have my segments. And while we're at it, let's color those segments a different color than those that connect to P. Let's make these red. All right, so let's say that we were to run from U to Q to the tent. Now this makes no sense because we're not running to the river, but hold on and let's see what this would imply. How would the distance of running from U to Q to the tent compare to running from U to P to the tent? Well, the geometric definition of the ellipse ensures that whatever location we pick along the ellipse, if we go from one focal point to that location and the other focal point to that location, the sum of those two distances is always constant. So no matter where I drag point Q, whether it's here at point P or elsewhere, the distance from U to this point to the tent is always the same. And if I make my ellipse a little bit larger, the sum of these two distances is now larger also, but again, it's constant for every location of point Q. So how does this help us? Well, let's look at these points that are inside the ellipse that are along the river's edge. And those are the points specifically that are between P and Q. So these. What if I were to run to one of these points? How does it compare to running to P or running to Q? Well, since these are points that are inside the ellipse, I know that these are better locations because the total distance is less. So I'm going to, how about delete point Q? I'm not going to need that anymore. Okay. And now that I know that these points that are inside the ellipse are better than point P, I'm going to move point P over because this clearly is not the best place. All right. So now I still have some points that are inside the ellipse, and these are still better than point P. So I can keep dragging and dragging, and when should I stop? Well, when I get to a place where the river's edge is tangent to the ellipse, then I know that all of these locations along the river's edge are farther away to run than point P because they're all outside the ellipse. So this location of P, where the river's edge is tangent to the ellipse, is actually the best place to run. Okay, one more approach. Here on this page, we again have U and the tent, and I'm going to use the segment tool as before to construct my path. Okay, and let's label that. Move this out of the way a bit. Label this here as point P. All right, so I don't have any actual measurements shown here, but if I were to measure the distance from U to P and add it to the distance from P to the tent, I could graph that right above point P. And I could, as I drag point P, imagine that for each location of P, I could mark the total distance that I would have to travel right above point P, and I could create for myself here a distance on a location, I should say, on this horizontal axis, and a distance being plotted here if I had a vertical axis. So how can I actually plot that distance? Well, I'm going to use the Circle by Center and Radius tool. So I'm going to click on that, and it gives me a circle that's defined by this glowing radius. So I'm going to start by constructing a circle whose radius is equal to this segment from U to P. So I'll tap directly on that, and I want the center of this circle to be a point P. So I'll tap on P. All right. So now I have a circle with radius UP. And if I now use my perpendicular tool to create a perpendicular to the river's edge, so I'll tap on the river's edge, and I want that perpendicular to pass through point P, so I'll tap on point P. Then I know that if I now construct a segment from P to here, the intersection of the circle with the perpendicular line, I now have this radius that sits perpendicular to P that represents my distance from U to P. So I've now transferred this distance to here. Now I'm going to do the same thing with the distance from P to the tent. So I'll again click on Circle by Center and Radius. I'll make the radius equal to the distance from P to the tent, and I'll make the center of the circle right here. And let's mark that also with the segment. Oops, let's move that to here, and the other endpoint to here. So now this point, and let's give that point a name, point B, okay. So this distance, PB, represents the total distance that I run from U to P and P to the tent. And as I move P to different locations, the location of B adjusts itself so that it's always representing this segment, the total distance that I'm running. So let's hide a few of these parts. We have a lot here showing. Let's hide the circles. And how about we hide these segments? And let's hide the line. And let's then click the visibility widget again. So all of those are hidden. And while we're at it, let's hide this point as well. So we're just left now with point B. And as I move P again, this distance, which I can represent with a segment from P to B, is my total distance to run. So as I drag point P, point B is tracing an invisible graph of how far I run. Well, let's make that graph visible. I'll tap on the trace widget, and I'll tap on point B. And now, when I drag point P, we see that it leaves a trace behind. And I have my graph here representing my position along the river versus the total distance that I'm running. So that I can see somewhere along here, it's a little hard to tell exactly where, is this best spot for me to run. So we've looked at 3 different approaches to solving this problem. First, we looked at the classic approach of reflecting the tent across the river. Then we looked at an ellipse approach, which we'll revisit in our next blog post. And here we used some geometry and Web Sketchpad's trace functionality to construct ourselves a graph, even though we didn't know any of the actual distances.